Okay, let's talk about variables under radicals again, and the reason why I want to go over that is because I felt like that wasn't very clear in the previous video, so I want to show you another way of doing it. It's it's pretty much the same, but it's just a different way of viewing it. Just like before, we're doing things. Now let's just go ahead and get started. So remember, this example was from the previous video. So we had 80 fourth root of 80 times x to the fifth times y squared times z to the seventh. So let's go ahead and move this a little bit higher so we have a little bit more room to work with. Okay, so I want to start out doing the same thing we did before. So we have the fourth root of 80 is equal to 2 times 2 times 2 times 2. And then we still have the x to the fifth, y squared, z to the seventh. Okay, so we have 2 times 2 times 2 times 2 times 5 times this mess over here. So we're looking for groups of 4. Since this is the fourth root, we're looking for groups of 4. So we have 4 2's. We only have 1 5, but we have 4 2's. So let's go ahead and cross out those 4 2's. Okay, it's not crossing out. Wonder why. Oh, I see here. Okay, I messed up the code, but it's okay now. So then we have cross out one of the 2's and put one of the 2's, cross out 4 2's and put a 2 out front. So now let's rewrite this again a little bit more cleanly, and let's go ahead and do it on the next line. I'm going to do something else whenever I do that. Here, let me go ahead and write it out so we'll see it. Fourth root of 5 x to the power of fifth times y to the power of 2 times z to the power of 7. Okay, so go ahead and put an equal sign out front too. Okay, so now I'm going to go ahead and put on the next line. I'm going to rewrite this, except instead of putting 5 to the fifth, I'm going to go ahead and expand that out. So it's, well, let's go ahead and write it out. You'll see. So you'll have, this is equal to 2 times fourth root of 5, and then 1, 2, 3, 4, 5 x's, 2 y's, and 1, 2, 3, 4, 5, 6, 7 z's. Hope that fits on the line. Okay, yeah, we got plenty of room on the line. So let's go ahead and put dots in between them because it'll make it a little bit easier to see them. Oops. There's an extra dot that I don't need there. So then okay, so now, just because that way there's a little bit more space and we can see them. Okay, so now I want to cancel these the same way I did these 4. Okay, so these up here. Oh, except I'm missing an x. There are 5 x's, not 4. So let's go ahead and add that back in there. Okay, so 5 x's, 2 y's, and 1, 2, 3, 4, 5, 6, 7 z's. Okay, so now I want to go ahead and do this the same way as I did up here. So I want to take away 4 x's from here, 4 x's from here, and put an x out front. So, and then how many y's can we take out? Well, we can't take out any because we only have 2. So we need at least 4 to pull them outside of the radical. So we can't do that. So then, okay, here's one group of 4 z's. So we can cancel 4 of the z's, not cancel, I'm sorry, I keep saying cancel, but it's not actually canceling. 1, 2, 3, 4. Okay, so here's 4 z's that we can pull out to the front, and so we'll have 2xz, the 4th power of all this. Now, can we pull out another z? Well, no, because we've only got 3 z's left. So let's go ahead and clean this one up and say that this is equal to 2xz, the 4th root of 5, and we have 2 y's on the inside left. Oh, but also before we even get to the y's, we have an x left. I forgot about that x. So then we have one x left, 2 y's left, and 3 z's left. Okay, so 4 x's have been crossed out and put out front. 4 z's have been crossed out and put out front, and this is what we have left. And if you go back to the previous video, you'll notice that this is the same answer. So this is quite a bit easier, crossing out, doing it just like you do with the regular numbers. The reason I didn't do it before is just because what if you have like x to the power of 17? Well, you're not going to want to write 17 x's. But for smaller numbers, this does still work, and you're not going to have x to the 17 too often. So let's go ahead and do the same problem, but do it a little bit. Do the other way again, but this way will work, and this way will get you the correct answer. And if you want to write out 17 x's, that'll work too. It'll just take a long time. But let's start from here. Let's start from here and use the previous method that we had before. So let's start again from here, and just because I want to make it so that we can go ahead and just so that we can understand the other method, I want to go ahead and go over it again. So remember the rule that x to the power of m plus n is equal to x to the power of m times x to the power of n. So this rule right here, this is what we're going to be using. So we want to be able to pull out something that that we can take the 4th root of. So we want the largest number that is a divisor of 4, but is still less than 5. So what is the biggest number that's smaller than 5? Or equal to 5, but 5 doesn't work, so you can't take the 5th root of x fifth. So what's the largest number that is smaller than or equal to 5 that you can take the 4th root of? Okay, let me say that again. What's the smallest number less than or equal to 5 that is divisible by 4? Well, it's 4. So that means let's go ahead and rewrite this as 2 times 4th root of 5 x to the 4th times x to the 1st. Okay, and we haven't messed with these two yet. We're going to get to it. So the reason why I separated these out is the 4 is going to be able to be nullified, I guess you might say, by this 4. You can have this 4th root and this 4. We're going to cancel each other out, sort of. Remember, based on this rule. Let's see if I can type this out. So the nth root of x to the power of n, nth root of x to the power of n is just equal to x. So this is the rule that we're going to be using. So that means that this will be able to just become x out front. We're basically doing the same thing. We have 4 x's, and we're just crossing them out and pulling them out front. So that's why that works. But let's go ahead and keep going. So we have x to the power of 4 times x to the power of 1. What's the largest number that's smaller than or equal to 2 that is divisible by 4? Well, nothing. Because 2 is not divisible by 4, and nothing smaller than it, because 2 is smaller than 4. So we can't take out any more y's. Just like before, remember, we didn't have enough y's to cancel. Same as here, we don't have enough y's to cancel. Not cancel, I'm sorry, I keep saying that. It's pulling out, but it's not really canceling. Then we have for z, okay, what's the largest number, again, that is smaller than or equal to 7 that can be, is divisible by 4? Well, only 4. So that means for 7z, we're going to have 7 to the 4th, but we're also going to want to z to the power of 4 times z to the power of 3. Ultimately, what I'm doing here, and this is what I kind of want to get across, what I'm doing here is the exact same thing that I did up here. I'm just writing this as exponents instead of writing it out completely. So now we can pull this out, just like how we crossed out 4 x's. We can pull out this x, and we can pull out this z to the 4th. So let's go ahead and rewrite this as, if we want, let's write out the individual steps. So we can rewrite this as 2 times the 4th root of 5, or let's move this stuff around so that we can see it more clearly. I'm going to do it on the next line. So 4th root of x to the 4th times z to the 4th times 5x, and instead of x to the, well, I'm going to put x to the 1st for now, x to the 1st, and y squared and z to the 3rd. Let's see if I typed that out correctly. Okay, so all I did was I moved this x to the 4th and this z to the 4th to the front of this part here, because with multiplication, remember that you can rearrange your numbers this way. So we have 5 x to the 1st, y squared, and z to the 3rd is on the right side. So this is going to be equal to 2 times the 4th root of x to the 4th times z to the 4th times the 4th root of 5x to the 1st, y squared, z cubed. So now I just use the same rule that we talked about before, where you have there's the product rule for radicals. So now, what's going to be the 4th root of x to the 4th, z to the 4th? Well, this is going to be, I mean, you could probably already see it, but in case you don't, and I understand if you, obviously this can get overwhelming sometimes. This x to the 4th, z to the 4th is going to be the same thing as, here, let's just copy this so it'll go by faster. Oops, I didn't mean to get all that stuff. Okay, so this x to the 4th, z to the 4th, let's go ahead and rewrite that as 2 separate roots. I did something wrong, I think. Okay, so all I did was I used the product rule again to separate out these two radicals. So what's the 4th root of x to the 4th? Well, let's go up a little bit so you can see, remember this rule? So this is just x, and this is just z. So that means that this whole thing is equal to 2xz 4th root of 5x the 1st times y squared times z cubed. So now we can see, of course, this x to the 1st, I want to go ahead and just rewrite that as just x, just to simplify it a little bit further. So x, y, z, sorry, I just said x, y, z. It's 2xz times the 4th root of 5xy squared z cubed. And if you want to do this a little bit faster, you know, you don't necessarily have to do all these individual steps. I'm just saying that when you have this 4th root, sorry, not 4th root, this x to the power of 4 and the z to the power of 4, you can skip all these 3 steps here and just go straight from here to here, because all you'll be doing is you're going to be crossing out these 4 x's just like up here. So I hope that makes things a little bit more clear. So if not, always feel free to ask questions. That's it for this video. I will see you later.